Analysis of synchronous sequential circuits. Let's assume an elevator is a sequential circuit and we want to discuss different states in elevator. So state in elevator. What is the present state of elevator? Of course, present state is current flow location. So at any floor that elevator is, we can say that floor location is present state. What is next state? Next state, of course, is next floor location. Or we can say it's equal to present state plus input. For example, we are in floor 5 and we want to move 2 floors upper. So we say floor 5, which is input, plus input, which floor 5, which is present state, and number 2 is input. So the next state will be floor number 7. What is state transition? Of course, moving between present state and next state is called state transition. So moving between present state and next state. Okay, so this one is like different state and definitions for sequential circuits. Let's assume we have a flip-flop. We have a flip-flop and it has input and it has output. So input, output. Of course, the output, which is stored data, is called present state because the value of the output is like stored on the flip-flop until the next like clock cycle or next enable signal, and input value is next state because by activating the enable signal or clock signal, the input value will move to the output and becomes a present state. So at any flip-flop, input is next state and output is called present state. So let's see a sequential, a general form of sequential circuit. So general form of a sequential circuit is in this form. We have two circuits. One is on the top, we will have combinational logic circuit. Combinational logic circuit. And here for the next one we have memory element. What is memory element? We all know that memory element is flip-flop. And we have different inputs for combinational part of the circuit. So we have x1, x2 up to xn as input. We have outputs from the combinational circuit, which is Z1, Z2 up to Zm. These are outputs. We have some signals moving from the combinational part of the circuit to the flip-flop. So we can say Q1 up to QR. So these are the signals that going from the combinational part of the circuit to the memory element. Of course, we show these signals by capital Q, and on the other hand, we have signals going from the memory element to the combinational part of the circuit. Let me just fix it. Let's put X N here like this, and then connect Q1 here, lowercase q1 here, up to QR. Okay? Despite the combinational circuit that we have, we can have different numbers of the inputs and outputs. So here we don't have to have the same number of inputs and outputs. Despite of combinational circuit, we know that for any sequential circuit, the number of inputs and outputs should be same. Okay, so then each flip-flop gets one bit and returns one bit. So if we have n flip-flop, we can get n bit information and produce n bit outputs. So here we can say that the inputs of the memory element are defining next state as we discussed, and the outputs of the memory element represents the present state. Okay, and this one is a general form of sequential circuit. Okay, now we want to model these sequential circuits. There are two models for modeling these sequential circuits. The first modeling method is called Mealy model. Mealy model. Okay, in Mealy model, we have two concepts. The first concept is state diagram. State diagram. A state diagram is something like this. We have a circle here, one other circle here, lowercase q, uppercase q. We have a connection between these two states and x over z. Okay, so x over z, of course, x is input and z is output. Lowercase q is present state. Uppercase q is next state. And this arrow is transition. So how to read this diagram? If I want to read this diagram, I will say the system has a transition from lowercase q to uppercase q by having input x. By applying input x, there will be a transition from lowercase q to uppercase q, and the output of the system will be z. So let's just repeat it one more time. How to read this diagram. If input X is applied to the present state, the system will be changed to the next state and the output will be Z. So it's the way we can read this diagram. So let me just uh, have some notes here. We can say circles are states. So circles are states, of course. Lines are state transitions. Lines are state transition. And how to read? When input is X, state changes from lowercase q to capital Q and output is Z. Okay, it's the way we read this state diagram. We can show the same information by state table instead of state diagram. So let's see what is the state table. So state table. The same information can be shown in a table. So here is the table form of this state change. Columns shows input, rows are present state. And for example, we say if input is X, and present state is lowercase q, we move to uppercase Q and the output is Z. Okay, so this one is the way we show the Mealy model by a table. So inside this cell we have next state and output. Okay, so be careful for table representing, we have like this fraction form variables shows the next state over output, but for diagram it is input over output. Okay, but both of them have the same concept. Okay, and how many states we can have? How many states we can have? So we have a sequential circuit, and the question is how many states we are like we can have. Of course, the number of states depends to the number of flip-flops. And if we have one flip-flop, we can have two states because the output of flip-flop can be 0 or 1. If we have two flip-flops, we have four states. So we can have up to four states, not definitely four states. So we can say with our memory devices, if we have our memory devices, number of states, which is number of states is less than equal to 2 to the power of r. We can have maximum of 2 to the power of r states. But of course we can have less than 2 to the power of r. If you remember BCD counter, okay, for BCD number presentation, we need 4 bits, but with 4 bits we only show 10 digits. So we have 6 extra unused input combinations. So the number of states is equal or less than 2 to the power of n, not equal. Now it's time to see one example for Mealy model. So here we have the example. Let me just write it down. Given the following state table, draw state diagram and find the output if input sequence 0 1 1 0 1 0 1 1 0 0 is applied to the system. Given that we are initially at state A. So we should know at which floor is the elevator at the beginning. Okay, we need to know the initial conditions. And this arrow says that the first bit of the information enter into the system is this 0 on the right. Okay, let's see the state table first before solving the example. We need to have the state table. Here is the state table. Okay, input x and present state, input x like has two values 0 and 1. States are, we just call them a, b, c, d, and d0, c1, b1, a0, c1, d0, a0, b1. Okay, so here is the problem and we need to solve it. So let's convert this state table to a state diagram. How many states do we have? Of course, 4. A, B, C, D. Let's show them with circles. So state A is here, state B is here, state C is here, and state D is here. Now let's start from the first row, which is state A, and first column, which is input is 0. If we are, and by the way, it says that we initially on state A. Okay, so we start from state A. If we are in state A and the input is 0, the state changes to D and the output will be 0. So if we are in A and the input is 0, the state changes to D. So if the input is 0, the state changes to D and the output will be 0. Next column for state A, if we are in state A and input is 1, the state changes to C. So if we are in state A, input is 1, the state changes to the state C, and the output will be 1. Now let's move to the next state. If we are in state B and the input is 0, the state will remain B and the output will be 1. If the system is in state B and the input is 1, the state changes to A and the output will be 0. If the system is in state C and input is 0, there is no state change and the output will be 1. If the system is in state C and input is 1, there is a state change to D and the output is 0. If the system is in state D and input is 0, we will have a change to state A and the output will be 0. And finally, if the system is in state if the system is in state D and the input is 1, there is a state change to B and the output is 1. So it's the way we draw the state diagram using a state table. Now that we have a state diagram, let's apply the input and see what are the outputs. So we solve it in this way. First thing we need to show is time. Then we need to show input, state, current state, and output. Okay. So time starts from 0 and moves to 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. What were the inputs? We just copy the inputs from this from this information. So at time t0, the input is 0, t1 is 0, t2 is 1, and so on. So we copy those inputs here. So it's 0, 0, 1, 1, 0, 1, 0, 1, 1, 0. Okay. And what was the initial state? The initial state is state A. We need that initial state here. So we are in state A. And now let's solve it. It's very easy. We are in state A and input is 0. Let's look to the diagram. We are in state A, input is 0. What's going on? The next state will be D and the output will be 0. So next state will be D and the output is 0. We are in state D, input is 0. We are in state D, input is 0. We go back to state A and the output is 0. We are in state A, input is 1. So we will have this transition. This state changes to C and the output will be 1. The system is in state C and the input is 1. C and input is 1. The state changes to D and the output is 0. The system is in state D and the input is 0. The system moves to state A and the output is 0. The system is in state A and the input is 1. The state changes to C and the output is 1. We are in a state C and the input is 0, remains in a state C and the output is 1. we are in a state C, input is 1, the system moves to a state D, output is 0. Finally, we are in a state D and input is 1, moves to a state B and output is 1. Okay, so we did it. We just got the outputs based on the inputs. Okay, so this one is the output. This string is the output of the system. So if we want to show it, we can say output is 1 0 1 1 0 0 1 0 0 like this. So this one is the first output. So this one is one example for Mealy model. In the next lecture, I will talk about the next model for analyzing the sequential circuits.